to the platform throughout the presentations, and we will get to them in the Q&A session. So let us begin. Our first speaker tonight is Professor Mark Howden. Mark has been the director of the ANU Climate Change Institute since 2015. He is also an honorary professor at Melbourne University, a vice chair of the Intergovernmental Panel on Climate Change, and a member of the Australian National Climate Science Advisory Committee. Mark has worked on climate variability, climate change, innovation, and adoption issues for over 30 years in partnership with many industry, community, and policy groups via both research and science policy roles. Thank you, Mark. Thank you, Mr. Jones.
Thank you very much, Katarina, for that lovely introduction, and to welcome us all at ANU. And it's a great pleasure to see everyone here tonight, because, as we know, it's been a while since we've been able to do this thoroughly. So tonight, what I'm going to cover is an extraordinary year. So in some respects, climate change has been lost in the midst of COVID, but in many other ways, what we've actually seen is really substantial change in the last year. So the first thing that I put up is the calculation done by the Global Carbon Project and colleagues, and that's not insubstantial, but it has had effectively no change, observable change, in terms of the accumulation of carbon dioxide in the atmosphere. So good news, but it has to be tempered with the likelihood that we're going to bounce back to where things were before, or maybe even higher in this coming year or years. And so that's really crucial, because that will threaten our ability to keep temperatures down to 1.5 degrees, as I will show you soon. So as a result of those high levels of greenhouse gas emissions, because if we go back to that slide, every one of those 40 billion tonnes of emissions, about a quarter gets absorbed by the oceans, around about just over a quarter gets absorbed by the land, the trees, grunts and soils, and about half, just under half, gets accumulated in the atmosphere. And it will sit there for a couple of hundred years, and it will build on the CO2 from the temperature increases. So because of that half that is left in the atmosphere, we keep on seeing this increase in carbon dioxide concentrations in the atmosphere, just like we have here. Today, at Mauna Loa in Hawaii, the concentration is 416.5 parts per million, and it just keeps on going up, around about 3 parts per million per year. There's also record levels of methane, record levels of nitrous oxide, record levels of other greenhouse gases. So all of the key things that are driving climate change continue to go up. They're not plateauing out, they just keep on going up. And because we've known that if we put greenhouse gases in the atmosphere for a long, long time, more than 150 years, it is completely unsurprising that we see an increase in global temperature. So what this graph shows, which is the average is 2016 was an El Nino year, which tends to bump up global temperatures. This year it was a La Nina year, which tends to drag down global temperatures. So in the absence of a La Nina year this year, it is very likely we would have been again the hottest year on record. And you can see that in Australia we're not far behind. It was the 4th hottest year. Last year was the hottest year on record. And this was pervasive. This is a graph, from NOAA or NASA, and it shows the spatial distribution of temperatures. And you can see that this is, with the little exception of somewhere down near Antarctica, this was happening globally, as you'd expect from a global intervention like climate change. In particular, you can see right at the top, sitting up there around Siberia, was extraordinarily hot. And this got reported in the media with towns in Siberia hitting 100, that's 100 Fahrenheit, not Celsius, and luckily, and also the Arctic Circle getting the hottest year on record, driving down sea ice extent to the second lowest on record, and very, very much thinning that sea ice. So the Arctic is starting to open up in terms of shipping as a result. So we see this happening globally. It also happened in Australia. We all know what happened last year with the Black Summer fires, so huge costs in Australia, human death and morbidity associated with smoke. Anna Hunter's here tonight, and she was crucial in terms of getting effective responses to this. And we saw very, very substantial death and morbidity in the people who were affected by that smoke. And Anna Greta would probably tell you that we haven't seen the last of this. There are long-term impacts of this that will only start to accumulate and show up in years to come, of deaths of animals across our landscapes. We saw a massive area burnt, 18.6 million hectares, enough to actually affect the global climate because of the particulates that put in the atmosphere, so it actually cooled slightly the global climate. We also saw very, very clear fingerprints of climate change, a human influence on climate change in this through increases in fire extremes and various other factors. And for me, looking outside my window this morning and seeing a green, cool, wet Canberra, the difference that a La Nina year makes is just amazing, you know, compared with last year's dry, crisp, brown landscape. And that's what climate does for us. It can transform the place from almost unrecognisably from one year to the next. So climate is an incredibly powerful thing in our landscape, and so when it changes, we need to be taking very close attention to it. And of course, this is just a part of the global picture of increased extremes. So the fires in California, for example, the strongest cyclones ever recorded. And that list goes on and on. We're seeing very, very clear fingerprints of human influence on climate extremes across the globe. So it's not just happening on our land, of course, it's also happening in our oceans, and with that warming and the breakdown of Greenland and parts of West Antarctica and various other places, melting of glaciers, and we saw the consequence of that just earlier this week in the Himalayas, we're seeing increased sea level rise. And that, again, just keeps on going up and up, record levels last year. The ocean heat content also goes up. And incredibly consistently, we can see almost a straight line now emerging from that amongst the noise. So the oceans are heating with huge impacts in terms of marine life, such as Great Barrier Reef and coral bleaching there. So these are things that are already happening. And amongst other things, as our oceans heat up, the risks associated with very strong cyclones increase. So this is a study which just recently came out, which shows the fraction of cyclones that are category 3, 4 or 5, the really nasty ones. And pretty much right around the world, that fraction is increasing. So more of the cyclones that occur are these really bad ones. And so in the oceans that surround Australia, the Southern Indian Ocean and the South Pacific Ocean, we see that increasing trend as well. So more of the cyclones that are in our region are category 3, 4 and 5. And these generate, amongst other things, floods, and Aparna will talk about that later in the talk here. So we also, and so that was, in a sense, looking backwards. This is what's already happened. Now, this next part of the talk is actually about some of the science results, I think, from this year, which I think are really pertinent to this audience. And so this is the new science that's looking to the future and trying to figure out what's going to happen to us. So one of the key science outcomes this year was that we found that our previous estimates of the sensitivity of the global climate system to carbon dioxide have been underestimated. So previously, in the fifth assessment report, we saw the sort of range of possibles going from 1.5 to 4.5 degrees. That's the sensitivity, the amount of increased equilibrium temperature increase with a doubling of carbon dioxide. New results actually indicate particularly the bottom part of that is lifted up to 2.3 degrees, again up to 4.5 degrees, with much tighter constraints around that. So we don't see the same sort of possibilities of low sensitivity, but still quite strong possibilities of high sensitivity. So what this means is the possibility of having a high emissions scenario at low climate change is effectively gone. So we need to face up to this. We can't let it rip in terms of greenhouse gas emissions and just hope and cross our fingers that the climate isn't going to respond that heavily. Everything says from these results that if we emit, it's going to actually cause more temperature increase on average than we expected previously. And because we can't rule out the high end of that sensitivity, we could actually have moderate climate emission scenarios that generate very, very large climate changes. So the spectrum has moved to towards the more extreme. The other thing that's happened in terms of science in this particular part of the talk is that the time that we expect the global temperature to get to 1.5 has come back about 10 years. So if you go to the IPCC 1.5 degrees report in 2018, it said that was likely to happen around about 2040. Now it's the early 2030s. And WMO suggests that within the next 4 or so years, one of the next 4 years is probably going to reach 1.5. So these things are happening, and they're happening really quickly. And the more we know, in a sense, the worse it gets. Now, if you look at things like heat waves, this is a study that looked at heat waves in Queensland. And those studies basically show that regardless of the metric that you look at in relation to heat waves, it gets worse and worse. Whether it's the duration or the frequency or the intensity of those heat waves, it gets worse and worse. And what this particular graph shows is that at 1.5, we get around about 7 heat waves a year, that's the average duration of them, and around about 3 of them. Once we get to 3 degrees, we're getting something like on average 15 heat waves, and they're about 7 days each. So that means 100 days a year are going to be heat waves. And the implications of that for human health and for productivity and for the environment are huge. And you can see that it's not a linear change. There's a really, really significant acceleration of damage as we go up what sounds like relatively small numbers. If we look at other things which are, and when we look at the sort of impact across the globe, the impact is huge. Over 1 billion people are likely to be affected by heat stress each year. If you look at other things which are pertinent to Australia, drought, a global picture of drought which has just come out. Australia is one of the hotspots in terms of increasing drought. So those numbers are trend days per year. So if you look at a trend over 80 years, multiply 2 at the far end by 80, so 160 days of extreme droughts in those areas which are identified in that map in Australia. If we look at what's likely to happen within Australia, this is an Australian study, regardless of the metric, again, whether it's duration of drought or extreme nature of drought, is that drought is likely to get worse and worse as the century progresses if we don't control our greenhouse gas emissions. And what this particular graph shows is that as we go up towards 2090, is that for every region in Australia, drought gets worse, and something like an average of 50% of the time, we will be in what we used to consider drought. If we actually start looking at things like water availability, crucial to all of our inland cities in Australia, Murray-Darling Basin, environment, agriculture, mining. Again, a global study, and what this shows is in terms of total available water in our landscapes, which includes the rivers and the soil, etc., is that again Australia is one of the global hotspots, along with the Amazon. So significant reductions in water availability in Australia. And we're already water constrained, we already fight over water, we already have high water prices, it's a big issue, and it's only likely to get worse. So if we look at something like sea level rise, again, that story is the more we know, the more worried we get. So what this particular graph shows is that it shows on the bottom, it's the temperature increases, global temperature increases, and on the vertical axis, it's the sea level increase in metres per century. And you can see from this graph, say if you pick out, say, 1.5 degrees, just the temperature here, that's the lower Paris Agreement target. The IPCC fifth assessment report said on average, sea level rise would be about 60 centimetres per century. Once we went to the SROC, the Special Report on Oceans and Cryosphere, it bumped up. So this was just last year. It bumped up, and so we're sitting in the 70s. And then this new study, which uses historical information to a much better effect, is pushing that up to about 87 centimetres per century. And expert judgment for these two periods sort of would indicate around about 90 centimetres per century. Way beyond what we were thinking sea level would rise just a few years ago. So again, the more we know, the more worried we get. And if we look at, whoops, too far, oh that's right. So when we add all of those sorts of things up into sort of economic analysis, we see really big danger signs for our economy. So this is a headline just a little while back. So 25% of GDP at risk because of climate change. Not from a radical group, this is from the Reserve Bank of Australia. So it's not as though this is fringe stuff, this is pretty cool. And so we need, I think, to take this very seriously. So what are the solutions? So one of the solutions is the Trump solution. You just stop gathering evidence and then you don't have anything to worry about. And believe it or not, that actually had an impact in the public in the US. You know, bugger the idea of evidence-based policy, just go with what your gut feels. And so this is actually not, I mean, it's sort of sarcastic, but it's actually really worrying at the same time, that this is actually a way that things are done in some places, and not just some places, but the US. And so we really need to focus on having good evidence in our system, and we really need to focus on getting that information out to the public, which is why these sorts of meetings are so important. So luckily in Australia, we've got a public that gets climate change. This is a Lowy Institute poll which has been done over many years, looking at whether people thought they wanted a lot of action on climate change, a little action on climate change, or wait and see. And consistently now, it's sitting at around about 90%. So 90% of Australians want more action on climate change. And at the moment, they're not getting it. So there's this big gap between public demand and what our political system is delivering. And so we sort of need to think about this, but we also need to think about that role of science in this. And luckily, COVID, I think, has opened the door to much more effective discussions about evidence-based policy and the role of science in public debates here in Australia. And I think that's a really positive thing. And that has been helped by some very foresighted ministers, including Matt Keane from New South Wales. Now, the last part of the talk that I want to cover, because this pertains to what Frank, Yotso and Emma are going to talk about later, is what we call carbon budgets. So it's the carbon budget approach to analysing how much we can emit to stay within any given temperature. Now, I think this is really important because at the moment we're hearing a lot spoken about net zero. Net zero preferably by 2050, or net zero by 2045, or net zero by 2060 with the Chinese. And that's all well and good. But as I'll show you, it's not the main game. So what we have here is actually a really well-known relationship in science. So on the bottom, it's the cumulative carbon dioxide emissions from any given time. So let's say it's from 2020. And on the vertical axis, it's the temperature increase, the global temperature increase from pre-industrial. So as things accumulate greenhouse gas emissions, the temperature goes up linearly. So we've got good records of this. And that's that red line up and through the middle, the one on a slant, the one that goes through here. And because there's uncertainty, I've put this greyed out or pinked out area on either side. So there's some uncertainty around about this, because there's various sources of uncertainty. But if we actually want to use this, it's really important because that linear relationship allows us to very quickly and simply say, if we have a particular temperature target, like the Paris Agreement 2 degrees target, we can very quickly say, okay, 2 degrees, how much can we emit down here? And that's our cumulative greenhouse gas emissions we can emit and still stay within that temperature. So it makes a very, very simple linear transform of a temperature goal to a greenhouse gas emissions action. And this all sounds really good, but it's a little bit more complex than that. So when we put this in practice, say we had a 1.5 degrees temperature goal. So what we then have to do is we have to take account of a couple of things. One is that we've already stored up some temperature changes already in our climate system from past greenhouse gas emissions. So even if we went to zero today, temperatures would still go up. There's uncertainty about how much, but they still go up. So we have to allow for that. There's also non-CO2 greenhouse gases like methane, nitrous oxide, and CFC and various others. And we have to allow for that. So those effectively bring down the effective temperature a little bit. And once we've done that, we can sort of then start to sort of drop that line down from where that dotted line meets the red line. We can drop that down to look at cumulative carbon dioxide emissions that are consistent with that temperature. But before we go to that last step, we have to take into account Earth system feedbacks, such as if the permafrost melts, that releases carbon dioxide and methane, which warms the Earth a bit more, etc. So that's what's called feedback. So we have to allow for that, because that reduces the amount of emissions that humans can emit, because their nature is emitting those things. And then we actually end up with this remaining carbon dioxide budget. So that is simply the amount of carbon dioxide that we can emit and still stay within this temperature, in this case 1.5 that I was talking about. So this is a pretty robust system that we can use. And so if we actually look at using this, if we want to stick within 1.5 degrees and have a 50-50 chance of doing that, we can emit around about 390 gigatons of carbon dioxide over any specified time and still stay within that bounds. The unfortunate thing is we're currently emitting around about 42 gigatons of carbon dioxide a year. And so if you do the simple maths, 390 divided by 42, it gives us just over 9 years before we've run out of the budget of carbon dioxide emissions that are consistent with 1.5 degrees. So we can't afford to keep on emitting as we are, because that would force us to go cold turkey in a bit over 9 years, going from a full fossil fuel economy to a completely green economy, essentially instantly. And that's just not going to happen. Much, much more preferable is if we start to reduce emissions now, or in fact 20 years ago, and have a long, slow glide path to a safe future rather than going over the cliff. But what this shows is the cliff is perilously close. There is no time to waste. If we start talking about 2 degrees instead of 1.5, if we give up on 1.5, the number's 27 years, but that's not that far off if we're thinking about it. And that's a 2 degrees target, not a 1.5 degrees target. And if we accept lower chances, like a 30% chance of staying within the 1.5 degrees, then we can expand our emissions out a little bit. But the size of this is really interesting. If you actually look at the reductions of reductions of emission that COVID brought us, that buys us about 3.5 weeks. That's all. If you think about the pain and suffering we've gone through with COVID in terms of less travel, less air travel, reductions in office energy usage, etc., that buys us 3.5 weeks. So that gives a bit of a feel for the scale of this. So every year we delay instigating large-scale greenhouse gas emission reduction really matters. So the implications of this are quite significant. When you hear someone just talking about a net zero goal, say in 2050, they're telling you a minor part of the story. The important part of this story is a net zero goal is not fixed. If we take significant action now, we push out that goal, the timing for that goal to 2040 or 2050. If we don't take action now, we pull in that timing of the net zero goal and make it harder and harder to make rapid change. So when you hear someone talking about net zero, it should come as part of a package with a firm commitment to a time and matching interim targets for 2030 and 2040. Because that is what makes it a viable policy and makes it a viable proposition. If we only focus on the net zero, the wool is being pulled over your eyes. So we have to have that policy discussion and that public discourse which says we've got to take this seriously, we've got to have both a goal and interim goals, a net zero goal and the interim goals. And so really important, what I've shown you before in terms of those impacts, is that this is not a vanity project as has been termed by some politicians. This is actually crucial to the future of us as a nation. And as Frank will tell you, and as Emma will tell you, there are plenty of opportunities sitting in here. It's not doom and gloom. This is actually about just being rational about future choices and making good ones which are informed by good science. Now, a quick summary is the evidence of climate change and its impacts just keeps on the good news about understanding more about climate change, is that there's a rapid and substantial set of actions needed in terms of emission reduction and in terms of adaptation if we are to maintain a prosperous future for Australia. And really importantly, that is not up to one part of Australia, like the government, or one part of Australia, like individuals. It's up to all of us. So we all need to act together. Thank you very much.
Thank you so much, Mark, for that very sobering but very important overview of where things stand at the moment. Our next speaker is Dr. Aparna Lal. Aparna is a senior fellow at the ANU Research School of Population Health. Her research focuses on the environmental and social risk factors for a range of infectious diseases. She has an undergraduate degree in zoology, a postgraduate diploma in wildlife management, and a master's in wildlife science. She completed her PhD at the Department of Public Health at the University of Otago before moving to the ANU. She is currently a research fellow in the Environment, Climate and Health Group. Thank you. Please join us.
Good evening, everyone. Thank you for having me today. Today I'm going to be talking about the links between water and health. But specifically, I'm going to be focusing on the three main features of this water and health relationship that are going to be critical for us as we develop sustainable solutions in a changing climate. The first of these is that the water-health relationship is one that is a shared value for us all. I grew up in India and I was 22 when I moved to New Zealand to do my postgraduate study, and I had the most amazing experience on my first day there. I was cooking dinner when my flatmate came up behind me and filled her drink bottle in the sink and then drank from it. It was the first time that I had ever seen anyone drink directly from a tap in the sink. Fast forward to 2021, and most urban households in India today have filters that are directly attached to the pipes coming in. And that's how we still get our drinking water. In many households, we do like a double layer of protection where this filtered water is then stored in urns for a certain number of hours, which not only makes it cooler, but it allows any remaining sediment to drop down to the bottom and leaches out any of the remaining chemicals. But how does that actually relate to us here in Australia? Let's just take a moment to acknowledge the huge importance of water and health in our lives in the last 18 months. We've had one of the biggest environmental crises to date, and water was critical to that. We could not have fought the fires without water. It was our frontline response to fighting the fires, but it's also been our frontline response to COVID-19. Hand washing and our continued and clean access to running water is something that we don't have to think about. While Australia made headlines around the world in terms of people fighting in supermarket aisles for toilet paper, we never once had to stop and think about our toilets stop flushing the next day or our taps running dry. Water and health is truly a shared value globally, even here today. But it's also very much a shared vulnerability. Many of us know about the United Nations Sustainable Development Goals. These are a set of 17 global goals, all working towards an ambitious 2030 agenda of leave no one behind. Goal number 6 relates to water, clean water and sanitation for all. In July last year, the UN Secretary General gave an interview where he said the progress on Goal 6 was alarmingly off track in the middle of a global pandemic when hand washing was critical and access to clean water was essential 2.2 billion people around the world continue to lack access to clean water. Climate change will derail this even further. As we've just heard from Mark, our water resources are going to become more uncertain. But how does Australia fare in terms of progress on goal number 6? If we look at any of the global statistics, Australia is doing really very well. The World Resources Institute and even the United Nations Sustainable Development Goals update report in 2020 shows that 99% of all Australians have access to clean water and basic sanitation facilities. However, if we look at these statistics just a little bit more closely, we find there are a few holes in the story. Access to clean water in Australia is not equal. There continue to be remote communities in Australia who do not have access to basic water and hygiene facilities. What this leads to, unsurprisingly, is high rates of preventable infections in these communities. In central and northern Australia, for example, scabies is highly endemic in many remote Indigenous communities, especially in children. Up to 50% of children and 25% of adults are infested, which represents some of the highest rates of cluster rabies in the world. Studies in Western Australia have shown that 8 out of every 100 Indigenous children have been hospitalised with a skin infection in their first year of life. These are preventable with access to clean water. Australia's first national population-based survey of eye health showed that trachoma-related infection in Indigenous children was extremely high. While rates were less than 1% in major cities, they were up to 8% in very remote areas. Again, infection rates that can easily be prevented with access to clean and running water. There continues to be an evidence and action gap with regards to access to water and health in Indigenous and other remote communities, even before we talk about the impacts of climate change. Given that it's a La Nina year, I thought I would focus on talking about the impact of floods. We've all heard of day zero, but more often in relation to droughts or prolonged dry periods. Both Cape Town in South Africa and Chennai in India were due to run out of water in recent times due to prolonged drought periods. But closer to home, we also faced our very own day zero, but this time in Brisbane following the 2013 floods. And this was because turbidity levels in water treatment plants was 4 times higher than what they had experienced during the January 2011 floods, which means that the water filtration systems in our drinking water treatment plants could not cope with the sediments coming through. This resulted in a hugely reduced capacity to deliver water to Brisbane residents, and we almost had our own day zero. This was actually in the Canberra Times this morning. A lot of our swimming spots have now closed following the heavy rainfall. Bacterial loads in our recreational waterways are very high. Our recreational areas like Lake Tuggeranong, Lake Burley-Griffin, used for kayaking and swimming, have also been put on high alert for blue-green algae following these heavy rainfall events. But it's not just how much volume of water happens during a flood. It's also when these floods take place. And this is something that's really important for us to remember as we recover from the bushfires. Just after Bega in New South Wales recovered from the bushfires, they were subjected to floods. Once again, the water flowing into their water treatment plants was highly turbid, full of sediments, ash, soot and debris. This resulted in them shutting down the water treatment plant because filtration couldn't cope and carting in water at $30,000 a day. Even though The Brogo River Dam, which supplies drinking water to Bega, was at 110% capacity, so it was overflowing, but none of that water could be used for drinking. There were similar situations in Queensland and other parts of New South Wales following the fires. We've also seen that over 50% of all boil water notices for drinking water that have been issued in New South Wales over the last 8 years, from 2013 to 2020, were recorded in 2020 and months following the fires. This picture you see here is taken of the Mogo Creek a few weeks ago in December. And you can see that just following heavy rainfall, the water still flows red. There are exceptionally high levels of iron, manganese and nitrogen, up to 10 times the accepted level flowing through these creeks. While this is not a drinking water source for the community, it is a huge source for recreation and aesthetic, and has huge aesthetic values for the community. They measure their recovery from the bushfires through what happens in this creek, waiting for platypus, eels and water dragons, even now. And finally, I end by talking about the third most important characteristic of this water and health relationship, and that is it's a shared responsibility. So while we value our water and we share similar risks, what is different among all of us is the ability to reduce those risks. And so here, when I talk about shared responsibility, I am talking about how can we collectively develop sustainable and equitable solutions on a changing climate. Definitely there's going to be technology and engineering involved. These are just two of the projects that are currently taking place in remote communities just outside Alice Springs. Hydro panels are solar powered panels that can actually use water vapor from the atmosphere and convert it to drinking water. Whereas the portable water filtration, known as Project Gilby, 75 kilometers outside Alice Springs, is actually a completely portable water filtration plant that can be just transported from place to place on a shipping container. So not only does it develop or deliver clean water to these remote communities, but it's also addressing the fact that many of these remote communities have intermittent supplies or connections to electricity grids. The entire water filtration plant is run through solar and battery-powered solutions. These projects are a great start and no doubt will be an integral part of any solutions we come up with. But in order to develop systems that are going to be resilient and sustainable in the long term, health as defined by the impacted communities need to be at the center of our solutions. Technology and engineering will be some of the tools that we can use to achieve these solutions. We're now at a very exciting time as we talk globally about imagination, innovation and collaboration. We have also shown how flexible we all are when forced to be. And so in relation to water and health, I think one of our biggest opportunities lies in integrating how communities view health with our advancements in science, technology and the arts that will allow us to implement and measure progress of these community-led visions. I think this is how we are going to get to the 2030 agenda of Leave No One Behind. Thank you very much.
Thank you. Thank you so much, Aparna, for that really, really brilliant, important talk and for highlighting issues like imagination, innovation, collaboration, and for us to approach this with community-led visions that is so critical. So thank you. Our next speaker is Professor Frank Jotzo. Frank is Director of the Center for Climate Economics and Policy at the ANU. He is an environmental economist with focuses on policy for climate change and energy in the context of economic reform and development. Frank Jotzo is Joint Editor-in-Chief of the journal Climate Policy and a lead author of the Intergovernmental Panel on Climate Change 5th and 6th Assessment Reports. Thank you so much, Frank.
Well, good evening, and it's wonderful to actually be in a room with part of our audience tonight. So it's great. So look, what has changed? Just a decade ago, right, we would not have been talking, what we think is realistically about, net zero emissions, about keeping global warming to 2 degrees or less. 2006, the landmark British study was released, the Stern Review of Climate Change, and Lord Victor Stern actually, just about dismissed the possibility of 2 degrees and instead focused on 3 degrees. So we're in a much better place now. Okay? So emissions grew by about 10% from 2010 to 2019, taking into account the COVID dip of 2020. Emissions growth over the decade will have been very low indeed. That compares to about a 31% increase in carbon dioxide emissions the previous decade. Okay, so something's changed here. And of course that ambition of staying below 2 degrees no longer seems an outlandish one. So what has changed? The first factor, very large factor, is technology. Okay? So the costs of important zero emissions technology has dropped like we really didn't expect it would drop. Solar is now the cheapest form of energy in many parts of the world, the cheapest form of energy. Wind is not far behind in many other places. Energy storage has become rapidly more reliable and cheaper, including in very large-scale applications, like, for example, they are now planned for the Hunter Valley. And that also includes hydrogen as a possible long-term, very large-scale portable energy carrier. Electric car technology has made the kind of leaps and bounds that we really didn't expect would happen until the 2030s or even 2040s, just perhaps 5 to 7 years ago. The other main factor is business attitudes. Large parts of business now see the shift to a zero emissions economy as inevitable, if only because of the already observable climatic impacts that we have. But many businesses also now perceive it and see it very clearly as a business opportunity. Australia could quite possibly become home to very large-scale renewable-based industries, whether that's producing hydrogen, ammonia, chemical products, synthetic fuels, steel, aluminium. Many governments also view the shift to a net zero emissions economy as a way to reap macroeconomic benefits of the investment that flows. And that is a very different viewpoint from the traditional viewpoint of seeing emission reductions as a cost and as a brake on the economy. And we see that kind of sentiment echoed very clearly in part of China's national growth strategies, in Europe's Green Deal, and of course very prominently, very importantly, in the Biden-Harris administration approach to these things. So you hear President Biden talk about climate change very rarely without equating climate change action to the creation of desirable, stable, well-paid jobs. Now, how to get to net zero emissions? As Mark Howden mentioned, the process of decarbonisation, the speed at which we go, is terribly important in order to keep within any given carbon budget. Nevertheless, the long-term goal is net zero. What are the pillars of decarbonisation? First of all, a zero emissions electricity supply. That's at the heart of it. And the good news is we're already some way down that road in Australia. So almost all of the tremendously large annual investments in electricity supply infrastructure are in wind and solar in Australia, plus storage. Okay, and so we will see the new generation of energy sources crowd out the old, and we will not see significant reinvestment in fossil fuel-based energy supply infrastructure. Secondly, electrify everything. There's a lot of fossil fuel that we use directly in specific applications, in particular in our cars, in our trucks, but also for industrial heat, several industrial processes, and home heating and the like. Much, if not all of that, can actually be shifted to electricity, which, if carbon-free, then puts everything on a zero-emissions basis. Third pillar, industry and agriculture. Reduce emissions in every process as you can. New technologies. Shift to products that are lower in emissions, and better processes and practices all around. And then the fourth pillar, taking carbon dioxide out of the atmosphere through revegetation or through technological means of carbon dioxide removal in order to make up for the remaining emissions that will stay there even once we've done everything that is reasonably and economically feasible in terms of emission reductions. So the question of a net zero target has occupied a lot of the public space in this country and many other countries in recent times. Now, obviously, there's some shifts going on in terms of, how our Prime Minister, our government talks about net zero, and that, is of course obviously connected to the delicate politics of climate change, even within government and in any major party, in fact. There's also an element, obviously, for international signaling. So there's increasing pressure on Australia to be seen to be playing ball on climate change policy. That pressure is not coming just from Europe and the UK. It will increasingly and strongly come from the US, from the Biden administration, of course. Now, as the Prime Minister has said often, and I think very rightly, just having a target is not enough. You need a plan, you need a strategy, and ultimately you also want meaningful, shorter-term targets for emissions that guide investment and that guide policy action in the shorter term. Right now, there's precious little indication of strengthened policy settings and not very much by long-term strategies for reduced emissions as well. And so the recently released Future Fuel Strategy, for example, is an example of that. It's of course a document that has been in preparation for quite some time, as we hear, and perhaps that is part of the reason for what we see. And what we see is not really a strategy for decarbonisation of Australia's transport system, as could be done and would need to be done, but a strategy that implies very marginal change indeed. There are, of course, many effective policies and even frameworks at the state and territory level. Many of these will have significant effects, but they don't really amount to a national framework, and they don't necessarily give business the kind of foresight that is needed for substantial investment decisions. There's also, of course, the existing 2030 emissions target that, as it stands, is easy to achieve. The achievement of the existing 26 to 28% target relies in very large measure on emissions reduction in land use clearing, land use change already achieved, principally between the years 2005 and 2010. A lot more could be done. It is reasonable to expect that the United States will take on a 2030 emissions target. Presently only have a 2025 target. It's reasonable to expect that that target will be a significantly stronger percentage reduction than Australia's target, and that will shine a different light, obviously, on our national target. I'll finish up with some thoughts on a long-term strategy that is needed. And so that kind of analysis, not just technical analysis of the emission reduction opportunities, it is very importantly also to truly understand the economic opportunities and the social and regional ramifications that come from some of these fairly deep-seated changes that we will be making to our energy and industrial systems in particular. There's plenty of really splendid examples of such national strategies. European Commission, the UK recently, UK Committee on Climate Change, and really we just need to look across the ditch to New Zealand, where just a week ago or so, a really in-depth, well-thought-out strategy for how New Zealand can achieve net zero ultimately was released. There are tremendous examples of what I would posit is definitely needed in Australia. Elements of that are deep dives, obviously, on emission reduction opportunities, different scenarios for future technologies, right? We should not fool ourselves that we know how the future will play out, not in terms of technologies, not in terms of economic developments, and the process of developing such a national strategy is also tremendously important. If we want an effective national strategy for the economic transition, for the technological transition, for the social transition, then we need to have the major groups of stakeholders at the table, right? It needs to be an integrated effort, it needs to be society-wide, right? It cannot just be a document that is prepared behind the walls of government departments and then put out for internet-based consultation. Key points for Australia and all of that, really to reiterate, Australia can thrive in a net zero global economy. There's many angles for that, in particular for energy and industry. Very important to remember that net zero is not the same as zero emissions. Net zero means we will have some remaining emissions and we will compensate for those by way of drawing carbon dioxide out of the atmosphere. That relates very directly to the debate that's playing out in the policy sphere right now, and that is on the idea of a separate target for agriculture, or in fact the idea of excluding agriculture from a net zero target, which to my mind, or in fact from the view of analysis, doesn't really bear scrutiny. Because what you want to do is reduce agricultural emissions as far as possible and then compensate for the remaining emissions. And that makes perfect sense because, even if there is a premium paid on any remaining emissions-intensive agricultural goods, that premium can be used for offsetting emissions. And the final thought I'd like to close on that is, we're a large fossil fuel producer and exporter, and significant parts of our economy currently rely on those industries. Okay? Australia used to ride on the back of a sheep, right? There's an impression that we're now riding perhaps on the back of a coal truck. That will change over time, but we cannot pretend that this shift isn't happening. Okay? So we need to really confront the fact that this is a big shift for some regional economies in particular, and we have a clear obligation to actually come up with solutions and with roadmaps for how that change, in particular in some of these fossil fuel intensive economies of Australia, can unfold, and how public policy in the rest of the country will help make that transition a smoother one. Thank you very much.
Thank you so much, Frank, and for highlighting the importance of an integrated approach, bringing together all the stakeholders, and there are a lot of them in terms of climate change. Our final speaker today represents another set of important stakeholders. They will be coming to us over Zoom, so hopefully the tech is all good. Wonderful. Our final speaker is Emma Hurd. Emma has been Chief Executive Officer at the Investor Group on Climate Change since August 2015. She has worked in climate change, sustainability, public policy, and finance for almost 20 years. Prior to IGCC, Emma spent 15 years at Westpac Banking Corporation, where she worked at the vanguard of climate change and finance. Thank you so much, Emma.
Okay, thank you, and hopefully you can hear me. Thanks very much for hosting me today. It's a real pleasure to be joining you, even virtually. I just wanted to start by acknowledging that I'm actually joining you from the lands of the Gadigal people of the Eora Nation, and I just wanted to pay my respects to elders past, present and emerging. and also pay my respects to the traditional owners of the lands from which you are joining, both in person and virtually as well. So I'm going to take a slightly different perspective in terms of the presentations that we've had so far, and come at it from the private sector dollars and cents kind of angle in terms of looking at the response to climate change, and in particular the kinds of decarbonisation pathways that we're seeing, that investors are looking for, and allocating capital to. And I want to just spend a little bit of time effectively taking a lot of the information that we've heard so far and flipping it into corporate speak, and then also talking through what it means for investors and for capital markets. And I'm going to start with the drivers of investor action on climate change, because I think what you'll see is that it picks up a lot of the themes that we've spoken about or heard about so far, but then also takes it through a different series of channels and thinks through a different set of implications in terms of what do you do with that information and how do you respond. So I want to start just by, again, going back to the Paris Agreement and just picking up on a couple of things that have been mentioned so far this evening. The first is very much this recognition around the framework that we're now operating in terms of recognising that if we want to have any hope of keeping global warming to less than 1.5 degrees, that we really need to be thinking about it in terms of carbon budgets aligned with net zero by 2050 or sooner, and we need to be translating the implications of those scientific information and findings and analysis into financial market analysis and response. And in that sense, you know, for many ways, you can think of the Paris Agreement and the framework, the taxonomy that is set up in terms of thinking about our real-world economy response to the science of climate change as a huge market signal in terms of driving corporate and investor and finance sector action. You know, I don't think it's any accident that in the same 2 weeks that the Paris Agreement was finalised, the TCFD was launched. And for those of you who are not familiar with the TCFD, it's the rather catchily titled Task Force for Climate-Related Financial Disclosure, which is why everybody calls it the TCFD. And it is effectively a voluntary task force that was set up to turn science into accounting and to translate climate risk into financial risk, and to find a way of fusing the two worlds together in actually motivating and incentivising our real world and real economy response to the effects of climate change. So Paris, the consolidation of the policy agreements, the kind of congregation around these key terms have ended up being really significant market signals over the last 6 years now. And I don't think it's any accident that you've seen this ramping up of private sector response since Paris, or this emergence of this framing device of 1.5 and net zero emissions. But I'll get into to some of the comments that have been raised so far about what does that mean in reality as I go. So in terms of also thinking through the drivers for investor action, again, it's that kind of combination of risk and opportunity which drives all investor action, all financial actors, I should say, as well. And I just want to unpack a little bit about how this is translating into the activities of the investor and the finance community. I'm going to start with risk. So a lot of what we're talking about in terms of decarbonisation pathways is about what kind of economic transition do we want to have in order to preserve our way of life and to limit global warming to 1.5 or definitely less than 2 degrees. So this transition, the transition pathways is a key factor. Decarbonisation pathways, but also nothing less than the fundamental rewiring of the entire global economy is what we're talking about when we're talking about transition. It has to happen from government, from individuals, consumers, in terms of products, in terms of industry sectors. And each industry sector has to go through its own transformation process around technology shift, energy consumption, carbon intensity of its systems and processes. The way we add them all up together to form our modern economy is the whole transition pathway that we're talking about. This is obviously going to present significant financial risks for key industry sectors that are most carbon intensive, but even across all industry sectors there are decarbonisation and transition risk implications. And effectively what investors are trying to do is get to the winners and losers of that transition. You know, part of that is also how as we begin to recognise the financial materiality of the transformation that we need, we also begin to see how this plays out in terms of the legal frameworks which govern investor practice and the financial system. So many of you would be familiar with recent findings, legal findings, around where climate risk sits within directors' duties, for example, or within fiduciary duties, the legal obligations that banks and that superannuation funds have in terms of how they're actually managing for delivering returns under appropriate legal frameworks. We've had a series of announcements around climate risk is a material, foreseeable and actionable risk, I'm using those words in quotation marks, which has to be therefore managed under those core fiduciary duties, under directors' duties across the financial and the corporate sector. We've also seen climate change itself has a cost, has an impact, presents risks to returns. Both in a couple of complicated ways. I mean, sometimes it's easier for us to think about it in terms of how this plays out in large pieces of infrastructure. So, for example, a port or an airport that goes out of operation has because of an extreme weather event, because of flooding, has its cash flows negatively impacted, has its returns impacted. And similarly, when you have huge heat wave effects, productivity goes down and you see less production across the economy. But also, it plays out in more diffuse ways. So, for example, when the floods happened major flooding happened in Thailand a number of years ago, there was a huge financial hit on the tech sector because everybody's component supply chains for mobile phones and smart devices were heavily concentrated in Southeast Asia, and in particular in large companies in Thailand. So an extreme event in Thailand can influence the stock value of companies like Apple on the New York Stock Exchange in terms of those integrated supply chains and how physical risks play out. And all of these are translated into financial risks. And of course, where there's risk, there's opportunity. And increasingly, we're seeing this recognition around the need to find green returns, as in like new emerging winners of the transition, the new technology providers, the new players, the next wave of Googles, the next big BHP. Where are they going to be in terms of this transition? But not just that, but how do the existing companies transition their portfolios, and who is going to effectively manage that well? This whole theme around transition finance is increasingly coming through around the trend of greening your portfolio, greening returns. So companies which are diversified miners with a large percentage of their portfolio in coal, selling off their coal assets, increasingly getting into exploration and scaling up of supply chains which support new clean tech technologies such as lithium for batteries, for example, or rare minerals which underpin a lot of the clean tech technologies that we need for renewable energy generation. So it can be the same company massively shifting their portfolio, and investors are trying to understand who's doing it well, who's doing it badly, who's got their head in the sand on these issues. And they're trying to do this because they're looking to future-proof their returns, and they're looking to manage carbon and climate risk opportunity across their portfolio at a whole portfolio level. So it also plays out across all sorts of different asset classes in different ways. So it's complicated, as with all things to do with finance. And this is why the regulators also get involved. So we've seen APRA coming out very clearly saying that they support the need for the industry to be managing climate risk as an issue. We've seen ASIC coming out saying that they are pushing companies as part of their core corporate disclosure obligations to be reporting on climate risk impacts for their business. We've seen the RBA coming out and saying that they recognise climate change as a systemic risk across the Australian economy. And it's not just a cyclical risk, such as a significant drought, but it's a structural risk, as in it's a long-term, continuously impacted issue which will affect the dynamics of the Australian economy in ways that we need to understand. Which is why they're participating in that last little acronym there, the NGFS, the Network for Greening the Financial System, which is all the regulators around the world coming together in their own club to try and work out how it sits within their supervisory responsibilities as in terms of oversight of the financial system for their regions, and then how that fits together in terms of the global economy. So there's a whole conversation, a very detailed conversation going on about taking science and turning it into financial risk. And this is not without its challenges. And I say that because, in fact, an article came out today, published in Nature, talking about the challenges of the fact that scientific models and climatic models are not purpose-built as financial risk assessment models, And at the moment, we haven't quite managed to fuse the two together yet, but you are having financial risk and financial risk modelling assessment being done on those existing climate risk models. So this is a real capability gap and a huge data challenge that both the scientific community and the finance community are trying to identify and solve for at the same time. So just in terms of time, so what are investors doing in this incredibly complex and challenging landscape? And in particular, in terms of an update, thinking through, where are they at right now and where are they going in terms of some of the challenges that they're facing in trying to manage for decarbonisation. And in particular, I think increasingly there's this thinking that they are looking to invest for a climate resilient net zero emissions economy. And that tries to capture the fact that we need to acknowledge that we are already at 1.1 degrees of warming, the effects will continue to grow, but also that we need to avoid the worst of those costs and effects by rapidly decarbonising. Like it or not, I'm sure we can discuss that net zero has become the North Star, which increasingly the financial community is gravitating around, heading towards, even while working out how to reverse engineer it back to more immediate investable timescales. Two charts here. I don't expect people in the room necessarily to be able to see the microscopically small font here. I just want to point you towards two things. This comes off the back of a survey that IGCC does once a year annually. We have done for the last 4 years. Looking at asking investors, what are they doing in response to climate change? And these two graphs show where we've asked investors to identify what asset classes they have undertaken a climate-aligned transition analysis on, and then separately where they've undertaken a physical risk analysis on. The green is yes, they have undertaken one. Blue is no, but actively considering. Orange is no and not thinking about it. And I think what you see here is listed equities, which is on the far left on both, very strongly represented in terms of a transition analysis, but on its real estate and property, which is very strongly represented on a physical risk analysis. But you can see how the different risks play out in different parts of the investable universe. You also see on the transition side, infrastructure, real estate, and fixed income, which is the world of green bonds, have come through really strongly in terms of the investor response. That's because it's slightly easier to do, and I say slightly, mainly because there are methodologies that allow you to do a more detailed transition analysis. And on the physical risk side, bonds are not as significant yet, although resilience bonds might be a different question, but property and infrastructure, large fixed assets, these are the real key areas where you're seeing a lot of activity in terms of physical risk assessment. So begin to see how the investor response is becoming more nuanced across the different dimensions of climate change impacts, looking for different elements of the problem in terms of trying to understand what they need to do about it in response. And then again, two small charts, apologies for the small font. The first one on the left, the multicoloured one, is proportion of investors setting a net zero emissions target by 2050. And how they've done it by asset class. And again, green is yes, blue is no, but thinking about it, and orange is no, not thinking about it. I think the most significant thing about this chart is the size of the blue bars. No, but actively considering. You know, in 2020, we saw a surge of institutional investment funds and companies, for that matter, announcing that they were starting with net zero and then looking at how they worked backwards from that in terms of their own company organisational decarbonisation pathway. But what you're seeing is this blue wave that's coming through behind them, which is everybody else, which is rapidly following. This is not unusual in terms of corporate practice, where you'll have the larger, perhaps more innovative, cutting-edge companies who do the groundwork, lay the pathway, and then you see the rest of the sector piling behind once the hard stuff's been worked out in terms of how to actually do it. So I think, you know, the net zero already seems like we've moved beyond it and we're focusing on 2030 or sooner, but in actual fact, we're really just getting going in terms of thinking about net zero as by 2050 or sooner as the kind of defining feature. And then if you look at the chart on the right, which is the blue bars, this is a slightly different question from a different piece of work that we did looking at company reporting on climate change and how investors use it. And really what we were trying to get to here is there's been this big push for companies to increase the amount of reporting and the corporate disclosure using the TCFD that they're doing on the impacts of climate change across their business. This is what the regulators are pushing for, investors are pushing for, governments are increasingly regulating to make mandatory, including in New Zealand, which is about to make it mandatory, for example. The biggest bar here is that what are investors using climate change reporting for? The biggest bar is engagement. They're trying to understand of the companies that they already hold, have shareholdings in, trying to understand what does that mean for the company? How well are they responding? Do they have a plan? What does the data tell them about how it's going to impact their existing holding, their existing shareholding? And then secondly, you see ESG integration, which is risk return driven. So the second one is very much around, then it's influencing, and they're using the information for investment. So how are they integrating climate information into their investment decision making? How are they incorporating it into risk assessment? How are they incorporating it into opportunity identification? Those two things I think are very closely related. Trying to understand the change, trying to understand how to protect themselves and generate increased risk-adjusted return, carbon risk-adjusted returns over the longer term for their beneficiaries, you or me, who have super funds or pensions. That engagement side of things is really important because it's also the relationship between investors and companies is also having a feedback loop, a strong response in accelerating private sector action on climate change. And I point you towards one particular initiative that's hugely significant in this area, which is called Climate Action 100+. So IGCC, full disclosure, IGCC, we were one of the 5 founding global investor networks that set this initiative up. It was launched in 2017 at President Macron's One Planet Summit. And it now has over 525 actually global investors managing a somewhat eye-watering US 52 trillion in assets under management participating in this initiative. It's bigger than Ben-Hur, basically. In fact, it's actually the world's largest ever global investor collaboration on any topic, let alone just on the climate space. It seeks to identify the around 160 odd largest systemically significant corporate greenhouse gas emitting companies, which is technical speak for the biggest emitters in the world across different markets in different industry sectors. So the big influences in their world in terms of the companies. In the context of Australia, there's 13 Australian companies on this list. It includes companies such as AGL, Origin, Woodside, Santos, Woolworths, Qantas, Adelaide Brighton, Boral, for example, BlueScope Steel, a range of different companies across different industry sectors. So you begin to see the big influences in their industry sector. And it's really asking these companies to do 3 things: to put in place effective corporate governance around climate change, to align their business strategy with a decarbonisation pathway, and then to report against the TCFD on the outcomes. Of course, that's hugely complicated. To support that, we also had to build a significant benchmarking framework, which we released last year, which breaks it all down into micro-specific elements. And then in about 3 weeks' time, we're launching the first company-level assessment of the Climate Action 100 companies against this benchmark framework. I mentioned this is really important because it's also symptomatic of what we're seeing across other industry sectors, in terms of industry sectors having to collaborate to work out how to effectively build the plane and fly the plane at the same time when it comes to decarbonisation. We need to be rapidly decarbonising at the same time we're working out what's the most effective thing we can do. And for investors, Climate Action 100+ as an initiative has become one of the key driving programs really pushing and accelerating investor action in this space. So I'm conscious of time, so I just want to finish with a couple of additional thoughts and observations just to throw into the mix before we get into the Q&A, just in terms of what we've seen by the way of investor practice and also what we're seeing coming up in 2021. So I just want to start with the observation that, for a long time, for a few decades now, we've tended to think about environment and climate issues as being about having a moral or an ethical position on key issues. It's the responsibility of the individual to make sure that their money and their retirement savings is invested in activities which align with their personal values. And this is definitely true. And if anything, as consumers become more proactive in managing their super and their retirement savings, this issue around ownership of our money is definitely increasing. But it's also become a whole discipline around recognising that environment issues like climate change are fundamentally financially material issues in that a company's performance on climate will influence how profitable it is, particularly for long-term investors like institutional investors. Now we're moving into this new phase, which is actually that this is about, as I said, nothing less than the transformation of the entire global economy along a decarbonisation pathway. These are big systemic issues which don't just influence one company in one country, but actually influence an entire global industry sector and how it interconnects with other global industry sectors. So this SRI to ESG to mainstream, or the growth of green and the greening of the brown, the whole economy, these are fundamental concepts that are changing the way the financial system is operating. People thought with COVID, when it came through in 2020, that we would see the same as what we saw with the global financial crisis, that there would be a pause in that momentum, that there would be a de-acceleration of activity across the finance sector. In actual fact, what we've seen is the polar opposite. My view is that the disruption, the widespread and wholesale economic disruption caused by COVID has actually created space for a more aggressive leapfrog approach to decarbonisation. Whereas before we were in a very much an incrementalist approach, small steps safely made without rocking the boat too much. When everything becomes a slightly riskier and a slightly more unsafe investment, then you go for the investments which have the more longer-term safety, which include clean tech, for example, social affordable housing, and different sorts of investments. That's what we're seeing the private sector doing, even if it's not always reflected in the politics. And speaking of politics, we've had this in Australia, our entire climate debate has been dominated by the politics of climate change. Whereas in actual fact, there is something bigger than politics going on in Australia. We are seeing this once in a generation transformation of our economy, and we have the obligation and the duty to get it right, not just for our kids and grandkids, but for the next 100 years of Australia's economic prosperity. And we have to do it in an environment that's warming, in an environment that's already got extreme weather conditions. And we have to be capitalising on the opportunities that are coming through and investing in solutions heavily in order to reap the rewards of the transition that's happening, as well as managing the risks. Underpinning all of this is data. Data is huge, and the drive for competitive differentiation is huge as well. So I'll pause there. I'm a little bit over time, and just kind of end up saying that that science and finance are definitely coming together in terms of how we're thinking through the transformation of the economy and the need to accelerate decarbonisation as well. Everything I've mentioned is on our website in terms of reports. I'll stop there and look forward to the conversation.
Thank you so much, Emma. Can I invite the panel up on the stage? Thank you to all our speakers for sharing your insights. Many of these issues are critical in the Pacific where I work, as the effects of climate change are felt on a daily basis there by communities. I don't know if some of you have been following the news, but as people are coming up on stage, there's been some galactic political shifts happening in the Pacific at the moment. Emma mentioned politics, and a few others intimated about how that, shifts our potential to work on some of these really difficult issues, but there's a lot happening in the Pacific at the moment. We are going to go to, for another 10 minutes or so, because we did start late. And I am going to try to consolidate some of the questions a little bit for our panel. But the first one, which I do believe Mark started to talk a little bit about, but has a second part that's quite specific, is during COVID, economic activity has slowed dramatically, yet emissions are down only 6.7%. What does this tell us about where we need to focus our reduction efforts?
It's a really interesting question, and one of the things is that GDP hasn't gone down that much. We've seen for a long time that GDP and greenhouse gas emissions are quite tightly linked, although that linkage is changing over time. But the big impacts in terms of COVID were largely on the transport sector. So when we actually break it down, the mines kept on working, and agriculture kept on growing things, and people were still, many people were still in jobs, but not everyone. The big hit was on transport, and that's only, depending on your country, but it's around about 1/7 or 1/5 of the greenhouse emissions. And so even though it took a hit, it was a temporary hit, people were driving again, and so the consequences in terms of emissions and GDP were relatively modest.
Yeah, it shows really clearly that we actually need decarbonisation of all of our systems. It's not just a demand side thing, right? With everything out of the transport and kind of office occupancy goes on as normal. And that's where the very large bulk of greenhouse gas emissions sit.
Does anybody else want to add to that? No? Okay. I'm going to go on to the next question, which is about tipping points. What is the latest on tipping points, when they arrive, when we lose control, etc.? How certain is our understanding?
Sounds like one for me again. Look, tipping points are really interesting. We've known for a long time that feedback's the fundamental in the climate system, the Earth system. So that the temperature is linked to carbon dioxide, which is linked to biospheric feedback, such as what happens in our oceans or what happens on our land. So feedbacks are not unusual, they're part of the story. The question with tipping points tends to be one of terminology where people are saying that, particularly where we get runaway feedbacks, such as if it warms sufficiently then permafrost starts to melt, we get methane carbon dioxide coming from that, which causes further warming and a runaway feedback. Again, there's differences in views, but my understanding of this is as long as we stay below 2 degrees, the likelihood of any of those tipping points becoming runaway is actually very low. If we go up to 3 degrees, then it starts to become more likelihood, and above 3 degrees, then more so. Having said that, tipping points are often easier to recognise in hindsight than they are with foresight. And our full understanding of these is still relatively limited.
Would anyone else like to add that? Okay. Moving further on from that, this question is, the ecological equation is impact equals population times affluence times technology. You suggest we could solve most of this with renewable energy technologies. Won't the other pollution impacts get too high? Can we really keep growing forever?
Yeah, so that question really goes to the heart of the challenge, and that is to take the greenhouse gas emissions output out of economic activity. Okay? Because if you take the question to the other extreme, right, then you would say, can we put economic activity down to 0, right? And obviously that's not desirable, right? And I mean, it's very, very promising development that we've seen over the last decade or so, and that is we've actually seen in reality decoupling of economic growth and emissions, right? So if you split it up, there's a very large number of economies where we now see GDP increasing and greenhouse gas emissions increasing, and that is completely against the trend that we've seen really since the beginning of the Industrial Revolution. It shows it can be done, and so the fears that we're curtailing economic activity in order to cut emissions are really shown to be misplaced. And so that particular trade-off, which is really a very fundamental trade-off, is beginning not to look like one that we need to be terribly concerned about.
Can I just add?
Go ahead, Emma.
I would just sort of say that also there's a couple of things that are worth including in this conversation. One is that we've been looking at projections of economic growth with only half the data, because we've actually not been looking at the quantifiable costs of environmental impact and degradation. So if we're not, this is not just in terms of pricing in carbon, but also pricing in health effects, pricing in, as we heard before, the health effects of water scarcity or water availability issues. We're actually not looking at the whole picture in terms of the cost of the growth that we've been driving for the last few years. Whereas in actual fact, and on the opportunity side, there's a huge amount of changed processes and companies coming through that are adopting a radically more efficient approach to our economic systems and processes. So furniture made from at least 80% previously recaptured waste. I was hearing something the other day about a brokerage platform that looks at waste, finds sellers of waste, and then links it up with buyers. and you can QR code the whole thing all the way through in terms of the supply chain of waste, and suddenly you have a brand new couch which is made at a tenth of the cost and 1/100th of the environmental impact in terms of the raw materials and resources that have gone into it. So growth doesn't have to be about willfully inefficient growth. We can grow our society and grow the net wealth for all of the participants in the society while actually reducing our footprint at the same time. And I mean, that's the opportunity part of actually dealing with environmental impacts in an opportunistic way, as well as in terms of a risk-based approach and a properly costed and priced approach.
Great, thank you. I'm just going to combine the next two because they're talking about carbon sequestration and carbon sinks. So recently, Michael Mann suggested that once we reach
essentially the locked-in climate change, that we still expect, on balance, that there is a residual temperature increase, even if we go to net zero pretty much straight away, and that's because there are other factors that are locked into the system. It will take some decades, I think, to turn the ship around, but if we take our foot off the accelerator and go to net zero, we will start to see improvements in a whole range of things. So, for example, Neroli Abram here at ANU was looking at these emissions substantially, whereas changes in some other factors will take quite a long time to slow down. For example, sea level will continue to go up for centuries. So different factors will change at different rates. In terms of seagrass, yes, those sort of systems can absorb a lot of carbon dioxide. They're very productive systems, but they can also lose that very quickly. And so if you're going to store carbon in blue carbon is called, in the sort of oceans, mangroves, seagrass, etc., it has to be done in a way that is not exposed to loss.
I'm going to change gears slightly here, and this is probably a question for the climate environmental, the scientists on our panel. Could you comment on the mental health of climate scientists? It is personal, but it is also indicative. There was mention, of vulnerable communities with respect to the impacts of climate change, and this question has indicated that, those people who are doing the research and studying these effects are also part of that equation in terms of thinking about mental health and well-being.
I'm going to give that one a go. So I guess in terms of mental health of the scientists studying climate change, I think it can be very doomsday-ish in terms of some of the evidence that we see. But I think from my perspective, as someone who studies the linkages between water and health, for me it's a time of great hope, because I see a lot of people. I see all of these young people who came to the talk today. I see great areas of hope where we can actually use some of the technology, the engineering, some of the investment solutions that Emma was talking about to actually improve society's mental health. And just from that, I think one of the things that we do need to think about going forward is when we're talking about things like economic costs, GDP, technology, and even things like tipping points, one of the key missing attributes in all of those is health. When we think about climate change and climate risk, the cost of inaction is actually quite high, and it's something we don't have a good handle on.
I'll just chip in there. I mean, my own personal take on this is you have to have hope because it's crucial that we can see a positive outcome and we can work towards that. But there's also a big measure of frustration that we've known what to do for a long, long time. We've known pretty much how to do it, but we haven't bitten the bullet and actually moved on that. And those things that Emma are talking about are really positive because that's a really strong message which has been sent by those $52 trillion worth of companies. What we see in other domains is, in climate change, is people who are acknowledging the climate is changing and are taking action in relation to that are much less stressed, they're much happier, and they feel much more empowered in terms of their lives. And I think that applies to climate science as well.
Would anyone else like to add to that? We do have to wrap up, unfortunately, and I have a few words from the Climate Change Institute perspective as well to add, but I do want to thank you all so much for the amazing overview that you've given, for the strategies, the approaches, for the different things that people need to consider. This is really an incredibly urgent issue that we need to be on top of ASAP. And I want to thank the audience as well for being here and participating tonight. Before we end, the Climate Change Institute is delighted to announce a new supplementary scholarship for emerging ANU PhD students. It's called the Game Change Fund, Supporting Climate Change Research. The goal is to support PhD scholars from rural and remote areas to contribute to game-changing climate change research, adaptation, and mitigation outcomes. We'd like to thank those who have made this possible, a group of donors led by Graham Waters, Anne-Marie Waters, and Ray Kiley. Now, if you're interested in finding out more, please contact the Climate Change Institute. I want to remind everyone as well that this event has been recorded. It'll be available for viewing on the ANU TV YouTube channel immediately after the event. So keep an eye out for that, and also more details on the upcoming interstate climate updates, which you'll also be able to watch online. So I have a last word from the Pacific, just because as much as we've been talking about all the different technical, financial, scientific, and other kinds of approaches that are needed to get on top of this issue, one of the most important things is really an overhaul of our relationship to the planet, an overhaul of our relationship to the Earth and this one home that we have. And people in the Pacific have been thinking about this for quite some time, for many, many decades, noticing what's happening in their environment. So as part of sharing how Pacific people have been talking about the relationship to our home, to where we live, I just want to end with part of a poem by a Chamorro poet called Craig Santos Perez, who's a professor at the University of Hawaii, and it's called Praise Song for Oceania. Praise your capacity for communion. Praise our common heritage. Praise our pathway and promise to each other. Praise our endless saga. Praise our most powerful metaphor. Praise this vision of belonging. Praise your horizon of care. Praise our blue planet, one world ocean. Praise our transoceanic past, present, and future flowing through our blood. Thank you so much to all of you. Vinaka Vakalevu, Kampasin Rapa. Thank you but I know that the questions that have been handed in will be incredibly important and informative for the Climate Change Institute. So thank you to our speakers. Thank you to all of you participants, and have a wonderful evening. Goodbye.